everybody, welcome back. We are going to begin Unit 6 today. 6.1 is Key Features of Exponential Functions. This whole last year with COVID, we have been kind of living the whole exponential growth curve on how things grow exponentially instead of linearly. And so we're going to take a look at that today. We're going to look at some of the key features of those functions. So first of all, let's take a look at just y equals 3 to the x. And notice it's not y equals x cubed. It's y equals 3 to the x. So our variable is actually in our exponent, okay? And so I'm going to start with some kind of wacky numbers here. Let's just go from -4, -3, -2, -1, 0, 1, 2, 3, and then maybe 4 again. So right here, this would be 3 to the -4th, which is equal to 1 over 3 to the 4th, right? Which is equal to 1 over 81. Okay, so that's a tiny, tiny little number. And then same thing, 3 to the -3rd. So right, well, very well with little tiny numbers. Equals 1 over 3 cubed, which is 1 over 27. Okay, this will be 1 over 3 cubed, which would be just 1/9. 1 over 3 to the 1st power would be just 1/3. 3 to the 0 power is just 1. 3 to the 1st is 3, 3 squared is 9, and then 3 cubed is 27. 3 to the 4th power will be 81, and it starts to get huger and huger. 3 to the 5th power is 243. And so these exponential functions just start to explode, and they're very dramatic. And that's why, you talk about, COVID-19 is an exponential growth curve. And actually, there's some arguments that it wasn't exponential, but that's a whole other thing. But the curve itself is exponential, and so it just explodes and explodes. Okay, so let's graph this. If we graph this guy, so first of all, if we go, let's make our scale. We want to go corp to 81. We're gonna have to make this maybe by 10. So let's make this right here 20, 30, 40 right here, 50, 60, 70, 80 here. Okay. And on down here, we'll just go ahead and go, this is going to be just 2, and 4, and 6. And we'll go right here, -2, -2. So just go by ones down here, -4, -6. Okay. So if we plot our let's just start with, I guess, first of all, just 0, 0, and 1. So 1's going to be way down here, right? It intercepts at 1. So that's our y-intercept. Okay. So whenever, usually, whenever, not when it's 0, but we'll have to look at the form of an exponential function, but this is going to be our y-intercept right here, 0, 1. Okay. If there's a number in front of that 3, then that will become our y-intercept. Moves it up and down. We'll kind of play with that in a minute. Okay. If it is 1, then it becomes 3, right? So 1 becomes 3, so it moves up a little bit. Okay. I don't know why it keeps doing this to me. Sometimes not very easy to deal with here. 1 moves up to 3 a little bit. Gosh, stupid thing. Try this again. There we go. Okay. And then, so move up to 2. Now 2 finally kind of starts to jump a little up to 9. So I guess 3 is a little bit kind of crowded. And then 3 jumps up to 27. So 3 jumps all the way up here to 27 now. So we're going to start to see some growth here. And then 4, it jumps up to 81, way up here. And if we put in 5, it's 243. And so, or excuse me, 4. Okay, so it goes way up there. If we go backwards here, -1, just -1 is just it's 1/3, right? It's 1/3, and it gets closer and closer. And 1/9, 1/27, 1/81. We never quite get to that x-axis. And so this becomes my asymptote. So horizontal asymptote. You guys remember what asymptotes are? Okay. So it never quite gets there. It gets very, 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 very close. Okay. So then it goes across our y-axis and then starts to just shoot up. Okay. And that's our exponential function there. Okay. If you take a look at the opposite graph here, or I shouldn't say opposite, but 1/3 to the x power instead of 3 to the x power. We take like 0, -1, -2, -3, and 1, 2, 3. This would be 1/3 to the 3 power, which would be then 3 to the third power, which is 27, right? So let's kind of go backwards from this one up here. So 1/3 to the -2 power becomes 3 squared, which is 9, right? And then 1/3 to the -1 power just becomes 3, right? 1/3 to the 0 power is 1. 1/3 to the first power is 1/3. 1/3 squared, you square top and the bottom, so that becomes 1/9. And then 1/27. Okay, so now if we graph those guys, again, 0, 1 is still our y-intercept right there, doesn't change. Okay, 1 becomes 1/3. And then, keeps doing it to me. 1 becomes 1/3. Come on. Need a draw for me here. 1 becomes 1/3. There we go, somewhere like that. And it continues to go on. Let's go back over here. We go -1 this time becomes 3, somewhere around there. And -2 becomes 9. So 2 comes up here closer to 9. Okay, and then -3 becomes 27, shooting up here, right? And then -4 could become my 81 way up here. Okay, so now what happens in our graph is instead of going up now, we're going to actually shoot down quite rapidly and then approach our asymptote. Okay, so you notice how this fraction actually makes it go down instead of up. So there's exponential growth and exponential decay, all depending on what this base value is here. Okay, what that base value is. Now what's my domain and range? So let's just look at we're just going to do this for our purple graph. So our purple graph here, my domain is all real numbers, right? It goes from left and right forever. So it's just going to be all real numbers. My range, however, goes from 0 up, right? So it's going to be all of my y greater than or equal to 0. Okay. Horizontal asymptote is my y equals 0 line, right? Just right down here. Okay. My y-intercept is 0, 1. Okay. So kind of take a look at all those and recognize some of those key features. Okay. So that is an exponential function. So definition of an exponential function here is a function in this form where we have a to the b to the x. Now you didn't see, technically this is a times b to the x because it's 1 times 3 to the x power. And notice this is my y-intercept. Okay. So you're going to notice that this a becomes my y-intercept there, because when I take b to the 0 power, I plug in 0 for x, that becomes 1, and then 1 times this becomes whatever a is. So that becomes my y-intercept. Okay. And then my exponent there, this is my base. And so this is my exponential function form. Okay. So what are the key features of this function? Include my domain, range, intercepts, asymptotes, and behavior, and so forth. So let's take a look at this graph now. Okay. So we have f of x equals 2 to the x power. So let's do the same thing where we just kind of pick some values, -3, -2, -1, 0, 1, and 2. Okay. 2 to the -3rd, 2 to the -3rd power ends up being 1/2 cubed, which is 1/8, right? 2 to the -2 power, if it's okay if I'm just going to put 1/4. This becomes 1/2. This becomes 1, because 2 to the 0 power is 1. 2 to the first power is 2, and 2 to the second power is 4. So if I graph this, of course, this is in the form a times b to the x. So the a there, when it's 1, it just leaves it as 1. But that's my y-intercept is 0, 1. That's my y-intercept. Okay, right here, 0, 1, my y-intercept. Okay, let's graph the rest of it. So 1, 2, 2, 4. If I were to plug a 3 in there, that would be 8, right? Up here to 8, and it would keep going and going. Okay, then backwards, of course, -1 would be 1/3. And then I would have my -2, we have 1/4, and it just gets smaller and smaller and smaller. So again, you can kind of recognize that I'm going to keep my asymptote right here on the y-axis, or excuse me, the x-axis at y equals 0. Okay, that's my asymptote. And the shape of my graph is going to be growing from bottom up here, and it's going to shoot up. Okay, shoot up here. Okay. So my domain, let's talk about my domain, is the same, left and right, it's going to be all real numbers again. My range is still, again, y is greater than or equal to 0. My y-intercept is 0. Oh, I should make that green, huh? 0, 1 for my y-intercept. My asymptote is still y equals 0. My end behavior, we talk about our end behavior as x approaches infinity. As x goes this way, my y is going to infinity. Right? As x approaches negative infinity, this way, y approaches, not negative infinity, it's approaching this line 0, right? Y approaches 0. So you have to be careful on that one, okay? Okay, so that is exponential graphs, okay? What are the key features here? So this is kind of an interesting one, okay? So let's take a look at this guy. Y equals 5 to the 1/2 x. So first thing I like to do is, what is giving me my y-intercept? It's going to be 5, right? So, because if I plug in 0 here, it's going to give me 1. Okay, so I plug in 0, it's going to be 1 times 5. So 0, 5 is going to be my y-intercept. Okay, if I plug in 1, that's going to give me 1/2 to the first power, which is 1/2, times 5. It's going to be 5 halves. Okay, if I plug in 2, that will just give me 1/4 here times 5, which is going to be 5/4. What if I plugged in -1? Right, that would give me 1/2 to the -1. That would become 2 to the first power, which would be 10. Okay, -2 would end up being, flip this around, it would be 2 squared, or 4, and that would end up giving me 20. Okay, so we can go ahead and graph this as 0, 5. We have 1 and 5 halves, which that's going to be 2.5, right? And then 2 and 5/4, which is 1.25. We might even want to do a few more just to kind of see where that graph is going. What is it, 1.25? There we go. Okay, if I plug in 3, maybe 1/9, 5/9, it starts to get smaller and smaller now. Okay. If I go -1, it gives me 10. So -1 gives me a period of 10, and I'm going to run out of space for 20. Okay. So I have this shape of this graph right here. It's going to approach my asymptote, y equals 0. Here's my y equals 0. That's my asymptote right here, y equals 0. Okay. What's my domain and range? Is x equals x. Oh, I should not x equals. It should just be all real numbers. Just write all real numbers. Okay. My y is still y is greater than or equal to 0. I shouldn't say equal to. It's actually greater than 0, right? It's not equal to the x-axis. So I apologize for that. It's not equal to. My y-intercept. We talked about that. Is this 0, 5? Okay, and so notice it's always going to be this constant number. Okay, so my y-intercept is 0, 5. Okay, my end behavior, as x approaches infinity, y approaches. So as x goes to infinity, what's y approaching? It's getting closer and closer to 0. Okay, as x approaches negative infinity, y approaches, so I go this way, y is approaching infinity. Okay, so those are our key features, okay, on how to find our graphs. Okay, so next I want to describe the graph in terms of transformations. So we're going to kind of take a peek at transformations and what those look like. Okay, so I'm going to actually open up a little tool here from Savvis, so we can kind of help us look at what these mean. We want to be able to identify intercepts, parent function, shifts left and right, and any kind of, stretches or compressions or anything of that nature. So I'm going to bring this over here and go through this. So here's my graph of y equals 3 to the x. It's one we just graphed a couple pages ago. Okay, so what would happen if I took this b? Remember that's b right here? My a is 1 right now. Okay, so let's look at a first of all. What if a was not 1? What if a was 2? Boom, also my y-intercept would be 2, right? What if a was, 3.2? What if a was negative? Oh, it's going to flip in the graph. So it's also responsible for reflections in our x-axis, okay? So that's what my a is responsible for. So not only is it responsible for my y-intercept, it's responsible for my reflections, okay? Let's look at b now. What happens to b? So b is responsible for how steep it gets, right? Because I'm putting a power in there. some number squared is going to get steeper and steeper. But what happens when it gets below 1? What happens when it's 1, actually? Let's look at see what happens when it's 1. Boop. 1.1, 1. It's just a straight line. It's no longer exponential anymore. Okay, it's just a straight line. Okay, so B actually has to be greater than 1 and less than 1 in order to be exponential. Okay, so then we go down here. What happens when it's below? All of a sudden it switches to a decrease, a decay, we call it, an exponential decay. Okay, if we get above 1, it's a growth because we're growing from left to right. If it gets between 0 and 1, it never goes down below 0. Okay, B has to be greater than 0. But if it goes between, if it's a fraction between 0 and 1, it's a decay. It's going down. If it's greater than 1, we start going up. Okay, if it's 1, it's a flat line, no longer exponential. Okay. So let's take a look. We'll put that back at 3. Now let's take a look at a K. What happens if there's a K out here? Okay, so we put let's see if I can find it here. Plus, like we put a K out, plus K out here. Let's go ahead and like right here. Here's a graph right here. So plus K. Okay. But what happens there? Well, now my asymptote starts moving. Okay, because I'm actually shifting my numbers up and down. That asymptote just shifts with it. So whatever K is, that's my asymptote. Okay, if K is, 3 to the X power plus 2, well, my asymptote is now 2. KY equals 2. Right, so that's what K does for my graph. Okay, so those are all my key features of my function. So in this case right here, it would reflect my graph in the x-axis, right? Reflect y equals 3 to the x over the x-axis. Okay, in terms of my y-intercept, that's going to stay the same. Okay, in terms of my asymptote, that's going to stay the same. Okay, only thing it's going to do is reflect it over the y-axis. Oh, I'm sorry, wait, the y-intercept, I'm sorry, is not going to stay the same. It's going to reflect in the y-axis. It's going to be -1. So my y-intercept is now going to be 0, -1, right? My asymptote is going to stay the same. My asymptote is still going to be y equals 0. Okay. My domain and range is going to change, right? My domain will remain the same. My domain will remain all real numbers. My range will change too. Let's see if we can graph this really fast. Let's see if I can graph this really fast. It was a let's see, 0, 1, 0, -1, and then we have 1. Let's see, 1, -3, 2, -9, like so. And so we're just going to kind of graph it like this. It's going to approach this guy like that. Okay. So now look at our domain and range here. Our domain is all real numbers. My range is going to be y is everything less than 0 now instead of greater than 0. Okay, so watch that, because reflected in the x-axis, our range changes to now less than 0. Okay, and let's see, I think we covered everything there. Okay, all right, so let's take a look over here. Graph this function. Describe the graph in terms of the transformations again. So now we have the same 3 to the x graph. The only thing now we're going to be doing is we're going to be shifting this down 4, right? Or shifting it down. Okay, so let's actually go back to our little tool here, and let's see what happens. We have this 3. Let's kind of just reset this guy. And so what happens if we take K and just shift it down 4? It just shifts down 4, right? What happens to our y-intercept? It gets shifted down 4, so now it's 0, -3. What happens to our asymptote? It just shifts down 4. Okay. Our domain and range actually stay the same for this one, right? Our range not quite. Our range doesn't go below -4. Okay, but our domain stays the same. Okay. So we go down here, and now instead of up here, we have our y-intercept at -3, and then we kind of start to grow up this way. So like here, something like this. I'm just going to kind of sketch the graph really fast. Okay, so here's my new asymptote. Okay, at y equals -4. Okay, so that shifts down -4 right there. All right. my y-intercept here, and write on the same, y-intercept is going to be at 0, -3. Okay, let's look at our domain and range. Our domain is still all real numbers, but our range has changed a bit because now it's going to be y is greater than -4 because it shifted. So it's going to be greater than whatever our shift was there. Okay, see, I think we have everything there. Okay, all right. Okay, so how do the asymptote and intercept of the given function compare to the asymptote and intercept of y of f of x equals 5 to the x? So notice that this time it's with the x, so this means it's going to be a left and right shift, right? Left and right shift. Okay, in this case, it's going to be shifting left. Okay, so we actually just do this. I'm going to be shifting left. I'm going to be shifting left 3, right? Okay, so what does that do to our asymptote? Our asymptote, I'm spell it here, does not change. Okay, no change. Because it still just approaches y, nothing changes there. We didn't move it up and down, right? Just move it left and right. But our y-intercept, however, that's going to be a different story, okay? Because if we shifted it left 3, if we plug in 0 here, so 5 to the 0 plus 3, okay, that's 5/3. And what is 5 cubed? What's that? 625? So it's going to be move up to 625. So 0, 625. Okay. And so we have to be careful with those and make sure you get those proper ones when they shift left, and just kind of make sure you get the proper, sorry, not 125, I'm sorry. Double check my math. 125, it's getting late at night, okay? So that would move up. So be careful on those shifts, just make sure, you plug in 0 and actually calculate those shifts, okay? And so 3, basically it's gonna be 5 cubed, it's up there, okay? All right, so you have a non-Excel worksheet in Google Classroom. It's just a few graphing problems. I think there's only 4. Just to get you kind of comfortable looking at the key features. I want you to make sure you graph and label everything, your asymptote, your y-intercept, everything, your domain and range and so forth. Okay, and then I will see you all in class. Have a good night. Bye-bye.